webinar of the Masters in Mathematical Sciences at Utrecht. As we just heard, currently a top educational program in the student evaluation in the Netherlands. Welcome to you. Let me introduce myself. I'm Gunther Cornelissen. I'm professor of number theory and geometry here. Next to me are two of our students, Mireia, there,
hello,
and Kai.
Hi.
They will later on explain their particular study program, and also I will ask them some questions in between and can react. We have a special setup in this kind of webinars. There is a chat box. On chat is our program coordinator, Barbara van den Berg. During this webinar, you can just type whatever question you have into the chat box. Either you will get an answer immediately, or we will get into it, or you will get an answer later. Barbara can help you with any question, so just go ahead, and whenever you think, oh God, I want to ask something about this, please just type it in. At the end of the webinar, we'll have a question and answer session, and then we'll get into some of your questions. And even if you have more questions at that point, you can still type them in. So I hope everything is okay. And let's get started on explaining a bit about this math program. We have a 2-year research master's. It's 120 European credits. It's quite a long program. Various honors programs that I will mention later. All courses are taught in English. Each year has about 40 students, and total will be around 80. It's a full-time study, and you can start at 2 particular entry times in September or in February. Most students will actually enter the system in September, but February is also possible. We have a special construction of tailor-made programs in different tracks. Here on the picture, I'm not going to name all of them. You see all our tracks, some of them overlapping. Let's see, what track are you in, Mireia?
So I'm doing the logic track.
Logic, okay, very pure person. And Kai?
I'm doing more applied. I do the complex systems track.
Right. You see a little box at the bottom, history of mathematics. Our department is the only one in the Netherlands that has a history of mathematics research section. And the little box is there to show that in any program, you can also specialize in the history of that topic. This is an extra feature that we have. Here is a program outline of these 2 years. You can see in the rows the first year, first semester, second semester, second year, first semester, second semester. In the schedule, there are 1, 2, 3, 4 colors. The big blue box near the end is your big research project that we'll get into later. The yellow boxes are so far unspecified courses that you can choose from large offering. One of them is green. It's a seminar. I will also explain a bit more about student seminars that we organize later. But I first want to focus on the red boxes. The red boxes are our common core program at the start of your studies. It consists of 3 components. These components are meant to do some community building, get to know your fellow students, make you grow into an actual mathematical researcher. So for this, we have these 3 things. I just wanted to mention that you see this box colloquium. Colloquium means that you attend and write little surveys about colloquium talks given by foreign visitors that we have, and maybe do some projects either in history of mathematics or in interaction between pure and applied math and robotics or something like this. An interesting course at the start of the very start of the first year is orientation, and I think Mireia is going to tell us what she did in the orientation course.
Yeah. So the course orientation in mathematical research, it's aimed at giving an idea on how to browse mathematical literature, how to learn from articles yourself, also how to work in groups. As a researcher, this is something that you have to do. So the actual projects that I had, you do 2 projects. I did addition of ordinals, that was more into the logic spectrum. And then I also did a project in game theory, evolutionary game theory, which is more outside of my logic scope, but it was also very interesting to touch other topics and see other ways of working. And it was really interesting because you really learn how to find relevant articles, how to study from articles, not necessarily only textbooks. Yeah, so that's part of this.
Big challenge to work in a team.
Yes, it can be.
Okay.
If you have a good team, it's very interesting and very rewarding. If the teamwork is not so fluid, then you need to develop your skills. But this is also a learning experience. So,
very good.
In any case.
Okay. Yes. Okay. Very nice. Maybe Kai can tell us something about his math for industry project.
Yes. So math for industry is also a course which is different from other courses because it's really one project that you choose. But this one has several projects that are given by partners from industry. And my project was actually from the RIVM, which is the Dutch research entity for climate and for the environment. And in this case, particular for radioactive protection. So my project was really cool. It was actually about if some measurement sensor somewhere in the Netherlands measures some radioactive level, then our task was to see or to calculate where that radioactivity actually came from. So we made a whole simulation and a whole program for that with a team of about 10 students. And it was really very different from other courses because you have to work in a team, you have to do a very concrete project, which was actually really nice. And I believe that it really helped the RIVM to approach the answer to the problem. So it was really nice, really fun to do.
We also really believe that doing these collective projects at the start really helps you in interaction with your fellow students, and will also help you a lot in your coursework. Actually, your mentality will probably change a bit, more research-minded, more talking to other people, admitting that you don't understand something, which is the default state of a mathematician, and talking to each other about it. I think this is a very important thing to learn. Okay, yeah, let's look a bit at how to fill up the yellow squares. For the yellow squares, we actually have something special in the Netherlands called Mastermath. Mastermath is a national course scheme, very diverse, broad, 60 courses on average to choose from, and you can fill the yellow boxes with any of these. They go in many specializations, and rather than me getting into the options, we'll get into specifically what you have chosen to do in your curriculum later. So what I wanted to mention is that we also offer local courses, and the local courses are actually organized in a bit different way. We just spoke a bit about these mandatory courses. We also have crash courses. We never know exactly in advance what they will be about, but we'll have one in May, for example, 1 week about topological data analysis. We have visiting professors giving lectures in the special colloquium we call the MONA lecture. We had Alan Sokal last year. We'll have Mathilde Macaulay this year. We will talk about models in linguistics that arise from mathematical physics. And you can go to schools. There are some schools organized by national research entities, such as Geometry and Quantum Theory Cluster, and that organize schools in 1-week schools, and these can also count towards your credits. One special feature is that we really offer a lot of student seminars. Student seminar means that the students explain to each other a piece of modern mathematics. And here is just a list of possibilities. Like on the picture, you see Mark is one of my students. He's explaining Galois homology to his fellow students. You give a lecture, you make a handout, you give each other homework, and in this way you work through a more advanced topic. There's also, you see these courses in topology, differential geometry is very big here. There's always a logic seminar, a mathematical logic seminar, and we have these applied seminars. For example, in epidemiology, we're quite big. We collaborate with the hospital, as Kai said. We collaborate with the National Health and Environment Institute, and we have programs in parallel computing and seminars in differential gradients and such. Yeah, so I think there's a lot to choose from, and the specific idea here is that, again, you learn by explaining things to each other. This is a challenge, but I think after you finish such a seminar, you really learn a lot about what to do. Right, let's look at the next point. The next point is this huge big block that you saw, the research thesis. It's 9 months of work on research. You can combine it with the internship. We will also see an example of that later. I think you are actually doing it now. Yeah, very good. And let's keep the suspense and not say yet what it is. What comes out of this is what we call publishable research. Publishable research can be very good exposition of something, all the way up to actually writing mathematical papers, contributing things. You see some pictures here and theorems from recent theses that later made it into papers, both in applied and in pure math. I think this is also very interesting to do, and please realize that this is a long, serious research project that you can do. Yeah, I would have really enjoyed doing such a long project somehow on my own. Yes. It's possible to do various honors programs. One of these is to do a double master's. I always make this joke: if you are not happy as a student only working also on Saturdays, you can also work on Sundays and do a double master's with theoretical physics. You have lots of experience with that because you have a very famous theoretical and climate physics department with climate physics, with computing science and artificial intelligence, which includes linguistic things, and also with history and philosophy of science. This is a specific, largish topic at Utrecht in the Descartes Center. And we also supervise the various projects in combination with this interdisciplinary institute. So double masters is like double challenge, but also double rewarding. So we also have our own master's program. It's called the Utrecht Geometry Center. This just requires you to do some extra EC, but it actually prepares you for doing a PhD research. Like our whole master's is on research, doing research, but you could do research in companies or outside academia. This is specifically searching for a PhD position, and we help you write CVs, we help you write and design PhD research programs. Yeah. And also it's selective, so you have to be admitted into this because it's some extra stress, so to speak. I think you are now doing this, right?
Yes.
Yeah, but in the first year. So the first year there's not much special happening, it's basically the second. Okay, good. Let's look at this one. There is a possibility 30 EC of interdisciplinary courses. You can do various such profiles and do applied tracks, and maybe Kai can say something more about this.
Yes, well, the applied tracks is really it's something new actually that comes in next year. But the idea already exists is that if you like not only doing mathematics but also doing mathematics, you apply to other fields, and this is really something I could recommend. I already do it during my my own track now. But basically what happens is that there's so many fields outside of mathematics where you can actually use mathematics, and everything that you've learned in your bachelor and in all these courses during your master, they can actually apply it. And there's a few examples there. For example, in for climate models, well, I did that also during my bachelor thesis, that how can you use mathematics to improve these climate models or to make them run more efficiently. And for complex networks, I also did a course on that. It's just a really fun topic. And that's for example, in marketing, it's very important. Like, how can you target the right people to get the most amount of views for your Facebook page, for example. And that's all fields where you actually need quite advanced mathematics. And that's, yeah, for me, it's really, really appealing to actually apply it to other fields. It's really nice that it's here.
Mm-hmm. Very good. I also wanted to point this cute picture in front of the very typical Dutch pancake house. It's a summer school in complex systems. You can also counting your credits. It's a very interdisciplinary summer school with students from all different science disciplines. Okay. Yes, let's wrap this up before we look at your specific programs. It's a challenging program. I think maybe the students can confirm this, but it's let's also use the word rewarding. If you want to do an easy master's, I don't think it's the right place for you. You have the possibility to make a very, very tailor-made program. We take your wishes very seriously in making. Your tutor will help you to design a program that fits your needs and interests. Our teaching is always linked to research. I think I made this clear. Research not just in the academic sense, but also in the very applied sense. And we collaborate. We actually collaborate as a large generalist university. We collaborate with many scientific disciplines on campus, also in other directions, in economical sciences, in biomedical sciences, with the hospital. We do statistics projects in hospital about, for example, now about mortality in intensive care departments. Very, very interesting possibilities here. Then the nice group of hardworking, motivated students. For this, I actually have this picture. Certainly. I have this picture here. This picture is our common room / library. And what you see here, it's really a typical day. So there's boards and students explaining things to each other. The tables are often used to work on projects. We also have a nice typical Dutch coffee machine there, and above upstairs is all the math books. So you can really also just consult the math books. There's a moderately quiet study area where you can use computers, and this is basically the central place for you as a master's student to interact. And this interaction, we believe, is very important to become a genuine scientist. Yeah, I think we try to make this possible for you. Right. Admission, you need a bachelor in mathematics or a bachelor that has a very significant component of mathematics, computer science, physics, statistics. If not, let's say, for example, typically engineering degrees are not sufficient to enter. If not, you can enter with a pre-master's. But it all depends a little bit on your exact prerequisites. And the best thing to do is to actually contact Barbara about this, and she can make a preliminary assessment of whether it makes sense for you to apply. There are application deadlines, you see them here. Non-EU students, 1st of April, EU students and European area students, 1st of June. Right. So now, Kai, please tell us something about your study plan and what you're doing, etc.
Yes, thank you. Well, first of all, I did a bachelor in physics and in mathematics, also in Utrecht, and then I already wanted to combine both. And as I said before, now I'm really applying my mathematics and also a bit of my physics to other disciplines. And that's why I chose the complex systems track. And that actually, the complex systems track is a few courses, and I'll get to that in a moment. But that all actually combines at your research master thesis at the end. And I try to combine everything I've learned and how to do that. And right now, I'm actually doing my internship in Den Haag for also a government research institute, but this time for climate change. And very short, but actually we need to raise some CO2 tax on emissions, and my job is to calculate mathematically what the optimal carbon tax would be for the next 100 years. So it's very mathematical, but it's also very applied, and I hope it has some applications for our daily lives, and that's at least I'll try to do part of it, and then someone else can do more about it.
Sure. Should we look at the courses?
Yes, that's a good idea.
Yeah.
So that's my all my courses I did over the past 1.5 years. And before I start about my courses, you see on the right, I also did a Young Innovators Honors Program. And that's actually really nice because it's not only with mathematics students, but it's really an honors program of 15 ECTS with students from other disciplines, really from medicine and psychology and social sciences and also mathematics and other courses. And what you do, you try to tackle a problem from the society, which is relevant for society right now. And we did a project on helping refugees to get follow online courses. So that's really nice. Then it's really you apply not your mathematics, but your knowledge, your way of thinking. That's really. Now about a few courses. You can see there's one seminar about modeling the health effects of ionizing radiation. Very complicated name, but actually it's also really, really nice because you then try to make a mathematical model of how radiation or radioactivity actually affects your cells and your body. And then with that, you can see what the maximum levels of radiation a body can take if you work at a nuclear power plant, or if there's some disaster, or if you go to medical applications. And it's very important to know what the effect is of radiation. And then we try to apply that to with a mathematical model. So that's really interesting as well. And maybe one more thing that I would like to talk about is understanding complexity. That was also a very interdisciplinary course where actually the students there are all from different disciplines, from economics and from climate change, climate science, and from also mathematics, but also everything else. Then you try you get lectures about different subjects on climate change, and then you try to tackle those problems with the input of everyone, and then it makes it really interactive and really broad. So that's really nice. That's actually the courses I would like to talk about.
Okay.
And yeah, I said already that I was doing my internship right now, but I'm not the only one. And I started this master with a group of people, and they're all listed here basically on screen. There's a few more, but these are all the people who took the complex systems track. And as you can see, hardly anyone is doing actually their internship or their thesis at the university, but we all do it at another company. And you see Laura is actually doing her internship at the hospital, and we've got Emily, who works at the KNMI for the Dutch Meteorological Institute, Winfried, who works at the bank, and so really have all different companies or institutes where we work for. And I think that's a nice example of everything you can do with mathematics, and especially mathematics in Utrecht.
Okay, sounds good. I think, yeah, you're on the next slide.
Yes.
Mm-hmm.
So I'm Mireia. I studied my bachelor in mathematics in Barcelona. And then I first came to Utrecht to attend the summer school in geometry. And I was really happy with the experience. So when I was looking for masters, I checked the one in Utrecht, and I was very interested in the tailor-made option that it offers that Gunther mentioned. And I will talk about it now. So yeah, that's what made me come here and do the logic track. As you can see, so I'm in my first year. I just started in September. So I started last semester with some of these compulsory courses with orientation in mathematical research. And then I took 2 courses from Mastermath. This is the algebraic number theory and algebraic topology. And then I took a course here at the Utrecht, the Foundations of Mathematics, to strengthen my background in logic. And now this semester, I'm currently doing the mathematics colloquium, mathematics for industry, and I'm doing my seminar as well on constructible sets. Actually, my presentation is tomorrow. And then category theory, which is a Mastermath course, and model theory, which will be a block 4 course. So I will do it in April and May. And then, as you can see, so as Gunther mentioned, I'm in the Utrecht Geometry Center. So I have to do this PhD research training. This is the gray box that you can see in my second year. And also, if you remember one of the first slides that we saw with the tracks that you can choose, there was this box with history of mathematics. And this is something that I want to do as well. And part of the things that you have to do to get this mention is do a seminar on history of mathematics. And this is something that I'm going to do next year, because I think the seminar is offered once every 2 years or something. And next year is going to be one of these seminars. And then I will have another course and my master's thesis. And actually, we were talking about this earlier. Probably now you can see it here as a 2-year block thing, but very probably I might take 2.5 years, because I feel that then it will not be so rushed, and I have more time to take interesting courses that are offered in Mastermath next year in the 2nd semester. So you have to be a bit strict, like, since you have so much freedom to choose your courses, it's interesting to be a bit strategic and think beforehand what you want to cover, and then check when it's offered and how you're going to organize that.
Sure. Yeah. Also, some students go abroad actually and take an extra half a year and do some courses there that are then set into equivalent EC here. Yes. Very interesting. Good luck with this. I think it's good if we switch to the question and answer session. We actually have a little screen hidden here with questions that you have been asking. So once in a while we'll look at that and try to answer some of the questions that maybe are of general interest. Please don't hesitate to just continue typing in questions, asking questions, and if we can't read all of them, then Barbara or someone else will actually answer them later. You can also contact us later. Let's see. There is a question by Tim. Tim would like to know, with a double bachelor's in math and physics, whether it's possible to do double masters in the profile applied analysis with physics. But you are not examples of this, right? No, but I actually had some students that did this. Yes, actually, we do have this double masters with physics, and we are quite experienced in interacting with the physicists in many levels. I would say applied analysis here goes very well in combination with climate physics, but also with condensed matter physics. There is a collaboration in variational methods between our institute and Marjolein Dijkstra, for example. So this is certainly possible. Theoretical physics, I actually supervise a thesis in condensed matter and number theory. This is a very interesting combination. I look at the elliptic functions in the condensed matter models. Yes, so I would say yes. Talk to your tutors in physics and mathematics, or actually ask us to figure this out for you, what the possibilities are. I'm quite confident that this combination is possible. Yeah, many people actually combine. The typical thing to combine would be geometry and string theory or particle physics, but these other options are very, very much coming into existence: biophysics, climate physics, etc. Very, very interesting.
If I can add to that, I would say what's the word? So my suggestion would be proactive in, if you have questions, contacting tutors. I think on the website with the list of tracks, you have the list of the responsible person for that track. And when I was considering applying to Utrecht, one of my interests is logic interacting with linguistics. So I emailed the logic tutor and I asked him, hey, if this is something that interests me, is this something that I would do with this master's? And he just answered and explained which courses I might be able to take in this direction. So I would say, if you're doubting, don't hesitate to contact people from yourself, and they are very much willing to answer your questions, or reach to students, or in any case.
Okay. There's a question by Ryan. Maybe this is something for you to answer. Ryan wants to know, in the modeling tracks, how much do you go into fields to which the mathematics is applied?
Yeah, that's a very nice question, actually, because I wondered about that myself as well. Well, actually, it really depends on you, on what you like. And I just did a course on mathematical biology, where you do a lot of modeling of biology. And in order to do that, you can really choose to either do the really, like someone gives you a biology problem and you just do the math, or you can actually dive into the biology to try to understand what is behind it. And at the end, we had to do a presentation, and then you could really choose where to focus on. I think this is quite typical for other courses as well, that if you apply it to other courses, to other fields. I also did a course on financial mathematics, and they really apply, you really go into the econometrics of trading, for example. And if you want, then there's plenty of opportunity to really dive into it. And if you don't want to, if you just are interested in the modeling or in solving differential equations, for example, then it's fine as well.
Okay.
So that's
I actually heard some students joke about this, that there's one kind of student that says, I'm not willing to discuss this PDE before I prove the existence of a solution. And the others that really don't care about this question. And this, I think, is kind of relates to this. I mean, there are various versions of applied mathematics. So from the very, so to speak, this doesn't make sense, the pure applied mathematics to the applied mathematics. I think we have some of all of this.
I'm really the applied.
Yeah, I understand. Okay, good. Let me look again. Anna wants to know whether there's a disadvantage starting in February. In a sense, yes, because Mastermath courses are tacted in such a way that the very basic courses generally start in September. But this only applies to very few courses. So I would say maybe it's not a very big disadvantage. Also, the number of people starting in February is a bit smaller, typically around 10 or so would start in February. What is another? Yes, and the mandatory courses, the orientation course starts in September. It means that your cohort starts without doing this orientation course in its first semester, it will do it in its second semester. I also think this is no big problem, because then you start doing the Math with Industry project, so you anyhow get to know each other. Yeah, so I think there is some minor disadvantage, but I would say not really, and many students do it and actually succeed just like the others. Yeah, I think this is true, right?
Yeah.
I think it makes sense. Yes, Chandras wants to know whether there's travel funds for students to attend seminars, workshops. There is a nice donation, a fund of the Mathematical Institute called the MONA Fund, and this has some money to spend on student travel, motivated student travel in relation to your thesis or whatever, each year. And some of our students use this to go to mathematical competitions, to go to a combinatorics conference in Czech Republic, also to travel in the Netherlands to Woudschoot numerical conference. There's various possibilities, but when the yearly budget for student travel in this fund is up and finished, well, then the answer is no. Yeah, so there are certainly some options and some possibilities. Let's see here. Another question was, can the master students be teaching assistants for undergraduate courses? Now, yes, definitely yes. Many of our master students. Do you both do it, or?
I do, yeah.
I haven't,
Yeah, okay.
but I plan to next year.
Right.
Yeah.
Yes. Yeah. So this is a paid job.
Fortunately.
Moderately paid job. Very nice, actually. I think it also kind of helps you in developing your math skills by explaining math to bachelor students. Is that true? And am I saying nonsense?
That's very true, yeah. And it really helps you. I think in mathematics, one of the most important things you have to learn is to learn how to explain it to other people. And the best way to practice that is either doing seminars or being a teaching assistant. And so it's, and it's fun to do.
Yeah, sure. Okay, here's another interesting question by Ryan. What kind of mathematics-related careers could you do after this program outside of academia? Yes. Well, this is very broad, actually.
Eternal question.
This is a very typical question. We have this, actually, let me get back to this slide. This would also typically be employers of mathematicians. Definitely. Yeah. So it's not true that you always go to banks or so. As statisticians, data analysts, but just also simple research scientists in consultancy or so. You're very highly valued, and the main point is showing analytical skills. The Netherlands has this very interesting infrastructure in which there are many non-university companies or semi-governmental bodies that do these research-minded things. Yeah. So of course, then it's not about having 9 months to solve a problem. The time for you to solve the problem is shorter, and the problem doesn't have to be very accurately solved.
Can be an advantage.
It can be, yeah, maybe it's better.
Not for you. But.
Yeah, but I understand the problem. But yeah, so there's many of these possibilities. I think this idea of analytical thinking and out-of-the-box thinking, this is very good. And in this sense, we actually have no unemployed mathematics students. This is very cute.
Wow.
Actually, most of them are being scouted and drawn into industry. Well, some of them already drawn into industry before they finish studying. This is a bit annoying for us, but maybe nice for you. Yeah.
And one thing I would like to add here is that, and this slide is actually very nice because a lot of people actually stay at these companies, but this is really for applied mathematics. But the same is really true for pure mathematics. It doesn't matter if you didn't do applied mathematics, you can still end up at the same places doing the same jobs. It's just really this way of thinking that's important.
Sure, yes.
Definitely.
So my number theory students are in data analysis, in financial markets, but also in security analysis, in image analysis, in biological use of machine learning in biology, for example. Very, very, very things, I would say. One of them is also a professional bridge player.
Can always try that.
Relevant. Okay, good. We are still in the Q&A. Let's look what we see here. What are selection criteria for someone to be accepted in the double master program? Asks Konstantinos. With a bachelor in mathematics. Well, I would actually say this is a typical question that has to be answered by the program coordinator. You have to be allowed into both master programs. But of course, in mathematics, you can be allowed with a good physics degree, and in physics, you can be allowed with a good mathematics degree. So let's just check your particular case and your particular course lists, and then this can be decided. So we would typically have a combined bachelor, master's, and physics from Utrecht, which then there's no question about whether it's possible to enter. This is study that you did. In other cases, I would really just do this on an individual case-by-case study. We just want to make sure that we only admit you to study that is reasonable for you to finish. I mean, it would be very frustrating to admit you into a master's in which the prerequisites are not good, and then it becomes very frustrating. I think this is the goal of the evaluation. Can I apply for a master in mathematics with a bachelor in physics? Yes, certainly you can. You need to look at what courses you did, what your mathematical background is, but this is generally possible. And actually, for example, in Utrecht, there are quite a few students that switch physics to mathematics, and vice versa. Yes.
As well.
Right. Do you have to travel to other universities to attend Mastermath courses?
Yeah.
Yes.
So the idea is yes, but for that the Netherlands is the perfect place because you're elsewhere pretty easily. The trains work. No, they work pretty good for real, and everything's close. So so for example, I have category theory in Amsterdam. I had algebraic number theory in Amsterdam. last semester as well, and yeah, it's part of the traveling. There's some courses, I don't know if this happens every semester, but there's some courses that are recorded.
Yeah.
So if one day you cannot really go to class, you can check the lecture online, which is nice. But in principle, to attend the lecture itself, you have to travel somewhere else. But Utrecht, Amsterdam, for example, it's 25 minutes by train, so it really isn't much.
And there's only a few courses. I know that there's actually only one that is in Twente, which is like the other side of the country. Even though Netherlands is not such a big country, it's still.
I was going to say that's not so far.
It's still not so far.
Yeah,
but most I only did courses in Amsterdam that were outside of it.
Very good. I think we need to wrap up. Let's say this was our last answer in the question-answer session live, but please continue to ask your questions. You can the chat will remain open for a few more minutes. Also, if you have any further questions, let me actually point to this to the website and also point to the email address of Barbara, the coordinator. You can continue to ask questions by sending emails to this email address. I hope you had a good time with us. Thank you for joining us. We hope to see you at the Masters of Mathematics in Utrecht. Thank you. Goodbye.
Bye-bye.
Bye.